Hello, my name's Katrina Holbert, and we're going to be talking about prosopagnosia. Start out with, let's look at the literature review and ask, what does the previous research even say about this condition? So, you may be asking, what even is prosopagnosia? It's commonly known as face blindness and is typically differentiated into two main types, developmental or congenital, and acquired. Acquired prosopagnosia, which I will be referring to as AP, is the inability to recognize faces as the result of a lesion in the brain or some other sort of physical trauma. Developmental prosopagnosia, or DP, on the other hand, displays the same face blindness as AP but is without the marked neural lesions. A key neural region typically involved in prosopagnosia involves a dysregulation in the right fusiform face area, or the FFA. However, other key neural regions may also experience disrupted functional connectivity, particularly the occipital face network. Although the development of the FFA is so crucial that even if the right lateral occipital region is still capable of performing some of the facial processing components, it is not enough to compensate for the loss of the FFA. Right, so while AP and DP do tend to share a dysfunction in the FFA, we should talk about some of the ways that they're different. The deficit in facial recognition developing from AP is suggested to result from insufficient perceptual and attentional resources for facial recognition, whereas DP seems to stem from encoding difficulties in advanced facial processing. And finally, those with DP appear to have impaired configural face processing, which prevents them from forming distinct facial representations.
Hi everyone, my name is Grace Franco and I'm going to be talking about the methods section between all 5 of these articles, and we're going to be looking at whether they are unbiased, reliable, and valid. First things first, I looked at the commonalities between all 5 of our articles, and they all seem to use relatively small sample sizes, primarily due to the rarity of the condition. And the majority of the population chosen for the studies were college students and or had education of past college. And all of the studies studied patients with AP or DP, and because of this constraint, the generalizability of the results be hindered as well as could limit future studies. Specifically in Zhao's study, the reliability isn't very valid because they used previously identified subjects with DP from a previous study done in 2016, which coincidentally is consisting of the same researchers who have done the 2016 and the 2018 studies, and Zhao was the leader in both. The population methods were not at all random and seemed highly controlled, and the results may not be as accurate nor applicable. And lastly, the Olivares, Zhao, and Zhang studies used EEGs and fMRIs to measure the brain activity occurring when the stimuli was presented. They used facial stimuli in either matching certain facial characteristics or memory and observing certain facial features or characteristics and having to remember them over a certain period of time. The Cohen and Zhang studies looked at brain mapping and neural lesions, specifically wanting to know what parts of the brain were affected and what functionalities were affected as well.
All right, I'm Lauren, and I'm going to be talking about what they found in the studies. So in one study by Zhang, they found that the fusiform face area is smaller in people with prosopagnosia than with those who do not have it. Other studies found that the fusiform face area has significantly fewer or disrupted functional connections. And in a study by Zhao, they found that those with developmental prosopagnosia had fewer connections in the right occipital face area as well as the FFA. Some other interesting findings from the studies were that, first of all, people with developmental prosopagnosia have issues detecting oddities in facial configuration. So people typically interpret faces using a T configuration with the eyes at the top, nose in the middle, and the mouth at the bottom. People with DP had a harder time detecting differences there. And another finding was that people with AP had lower facial discrimination sensitivity and mismatched faces both more often and faster than those with DP and the control groups. DP did not vary significantly in the time they took to match match or mismatch faces compared to control groups.
Hi, my name is Amy, and I will be reflecting on the discussion portion of these articles as well as their diagnostic implications. So corroborative studies have demonstrated that disruptive functioning in the right fusiform face area of AP patients and stunted growth patterns in the right fusiform face area in DP patients present compelling evidence of facial recognition task localization. Emergent research has also shown, however, that there is global and integrative functioning within this region. In addition to regulating the extended face network and core face network, lesion studies reveal that there are connections between the left frontal cortex and right fusiform face area. Due to its role in network integration, researchers hypothesize that prosopagnosia is a, quote, two-hit disorder that results from disruption of both the right fusiform face area and left frontal cortex. This two-hit model offers insight into non-lesion-induced prosopagnosia conditions such as DP and autism spectrum disorder, because it suggests systemic pathologies that arise from disruption in both these neural regions. This has allowed for more accurate diagnosis and identification of impaired facial recognition. Additionally, the identification of this global facial recognition network promotes more accurate prediction of subclinical facial perception deficits among stroke victims. This has allowed for more precise patient screenings as well as application of preventative therapies. So in sum, lesion mapping insinuates that there is a balance between neural specialization and global functioning within the facial recognition and perceptive network, which has informed more effective diagnostic criteria. Following this, we also have our reference slide.